Hello there, my name is Gene Chagas and today I'm going to be presenting a complimentary video that goes alongside with our publication. I hope this video can clarify some of the questions you might have upon reading our paper. Also, a full detailed presentation will be available upon acceptance. This work has been performed by myself, Roberto Torres Reis, and also our advisor, Dr. Paul O.
Right, first we're gonna have some experiments. This is a shopping cart experiment using a 6.5 kilogram load. Here you can see the humanoid DRC Cubo pushing this cart, which is a very large cart. Here is a cart experiment with just a different point of view. You can see the depth image on the right and the POV of the robot on the bottom left. Here, shopping cart experiment with the same load. Here you have a close-up on the foot. As you can see, the robot has a little bit slippery due to the glossy floor where this experiment was conducted. Here's a little bit of a challenge cart, which is the wheelbarrow. Due to its dimensions, it's a little bit challenging. You can see that the knee of the robot is cleared from the cart itself. Here another experiment, but now with the 5.3 kilogram load. You have a side view of this experiment on the bottom right. So now we're going to have an experiment where you can also see the real-time MATLAB simulation that is being done by using the whole body kinematics that we're discussing in the paper. Here overall ZMP results for those experiments. You can see that the measured ZMP follows the reference ZMP. And here is some experiments where the ground, instead of being the glossy floor, is now a carpet, and the robot is capable to push all the way up to 11.7 kilograms. This is here's a little bit of overall ZMP error analysis. Of course, the higher the load, the higher the chances are that the robot may fall over. We also did a residual square sum over time analysis, which we'll discuss in further more detail. Here are some of the ZMP results. If we have a close-up, you can see that both staying within the support polygon. Now, this is a very interesting experiment where we have a long walk. We had to ensure that the robot was able to walk for a long distance while pushing a cart. And this is one of the experiments where the robot has to take 50 plus steps while pushing the wheelbarrow. Here are the results for this particular experiment. Of course, so many steps, so it's quite hard to see. Now, this is for rough terrain walking. This is a very interesting experiment. We're trying to push the envelope here on the limitations of the robot. So we know we can push the wheelbarrow, but what happens when we have a drastic change within the terrain? And as you can see, the robot loses its foot and wind up falling over due to the irregularity of the terrain. We're still investigating this and improving rough terrain walking while pushing carts, and of course material handling in the local manipulation realm here. Here is exactly where that catastrophic fall happens, and that's where the robot falls. I'd like to thank you, and please, I look forward to publish a full presentation on this material and this work, and all the resources that have been used throughout this project will be available for the readers at a later time.